Hello everyone and welcome to the channel, Artificial Neural Networks and Convolutional Neural Networks. In this video, we'll quickly go through them to find out what is the difference. The idea of artificial neural networks is inspired by the structure of human brain, in which we have billions of neurons connected together processing information. And that's how we learn and build perception about anything in life. Each neuron in human brain has an input and output, which is connected to other neurons in the network, which are billions of neurons. On each artificial neuron, there is two processes taking place. The first process is that all inputs are multiplied by weights and then adding a bias to the summation. You can think about it as a linear regression. Then the output of this equation or linear regression is applied to an activation function, which is basically a nonlinear transformation to add nonlinearity to the output of the neuron. And that's why neural networks are powerful when working with nonlinear data. The activation function is also to decide how important this neuron towards the final output. In other words, to activate this neuron or not. There are different types of activation functions. You have the sigmoid function, which gives an output between 0 and 1. There is the tan function or activation function, which gives an output between -1 and 1. There is the ReLU, which only pass through the positive numbers. We can discuss activation functions in a separate video, but for now, all what you need to know is that an artificial neuron has input or multiple inputs multiplied by weight, adding a bias to the summation, which is kind of linear regression, then applied to an activation function to add nonlinearity to the output of the neuron, which is the final output of that neuron. Now let's take a look on the network level where we have multiple neurons connected as layers. We have the input layer, we have hidden layer or layers, and then we have the output layer. When you build a neural network based on your specific application and the amount of data you have to define how many neurons you want to have on the input layer, how many hidden layers you want to have, how many neurons on each of these hidden layers, and how many neurons on the output layer. The more neurons you have, the more layers you have, the more complex the network becomes, the more time it will take during the training process, and it could be more accurate. But potentially also there is a risk of overfitting. Now, since we have a network and we have defined how many neurons, how many layers, it's time now to train the network. That is to give inputs and outputs. During the training process, there is two processes taking place. The first one is called forward propagation. In forward propagation, all the weights and bias on the neurons will be initiated randomly, and then the output will be computed. And this output will be compared to the actual output, what is supposed to be. And then the error, the difference between the computed output and the actual output will be calculated. This is called forward propagation, to initiate the weights and bias randomly, to compute the output, and then compare it to the actual output to calculate the error. The second process is called back propagation. And in back propagation, the network will adjust all the weights in order to minimize this error. In other words, to minimize the difference between the computed output and the actual output. How this is being done is by using the first derivative of the error with respect to the weights in order to find the optimal minimum. In other words, trying to find the sets of weights that minimize the error. So to summarize this, when we first initiate the training process, all weights and biases on all neurons will be randomly initiated. And then going forward, compute the output, compare it to the actual one, calculate the error, going back, change the weights in order to minimize this error. And then going back and forth in this loop until we cannot further minimize this error. At this stage, we can say that we have the optimal output and then we have the optimal configuration for our neural network. And then we can test it and validate it using another data set. And convolutional neural networks. Convolutional neural networks are mainly used when we have images as the input data. We use convolutional neural networks for applications like image classification, object detection, face recognition, and so on. A convolutional neural network is basically an artificial neural network that we have already explained with adding two types of layers in the beginning, which are the convolutional layer and the pooling layer. The convolutional layer is about multiplying the input image, which is a matrix, by a filter, which is a smaller matrix, let's say 3 by 3, that has random values. So we start by multiplying this filter by the upper left part of the image and save the result as one new pixel in the new image. And then we move one pixel, multiply, and save another new pixel in the new image. And then we keep moving until we scan the whole input image to come up with a new image that is called the feature map. We don't multiply the input image with only one filter rather than multiple filters until we come up with multiple feature maps that contains the most important features of the input image. The pooling layer, if it is 2 by 2 for example, that means for each 4 pixels in the feature map, we take only the maximum one. For example, if the feature map is 4 by 4 matrix, that means we have 16 pixels. From each 4, we take only the maximum one. We end up having 2 by 2 matrix. This is to reduce the computation time and cost. So these two layers, the convolutional layer and the pooling layer, together they are called the features extraction phase. So we need to extract the important features from an input image. After the pooling layer, we flatten the matrix into 1D vector and then we connect it to a hidden layer and then we continue as the artificial neural network that we have explained already. So this is basically it. In artificial neural networks, we have input layer, hidden layers, output layer. In convolutional neural networks, we have the same with adding two types of layers, convolutional layer and pooling layer, to extract features when we work with images as the input data. And that is the end of this video. Thank you very much.